actually might be warm this weekend. Okay? Now, dress appropriately, you guys. Tomorrow morning's going to be 15 below. It doesn't take long to get frostbite. I know I have frostbite, and once you get it, it never goes away. So the minute I get out in the cold, those places where I had frostbite turn bright red, and they hurt. So don't be ridiculous and not wear a coat. It's going to be really cold. It takes about 1 or 2 minutes to freeze. That's all it does. Okay. Um, Here's what we're going to do. In this chapter, we're starting integral calculus. Okay, Jack? What happens when you accumulate instantaneous changes over an interval? This is the other half of calculus. It's the area under the curve. Okay, Casey, call it? So our goals today, and actually I'm going to cross one out, we're going to find the total distance traveled, and we're going to use rectangular approximation methods to find that. I didn't mean to cross that one out. We're not going to do the volume of a sphere. You will do something like that. I think that's tomorrow, out of the second day. Okay, so you guys, how many of you have had physics or are in physics? So you know a lot of this already. Consider a train traveling at a constant rate of 75 miles per hour for 3 hours. What is the total distance traveled? You know this from ninth grade physical science. Distance equals rate times time. Remember that? Let's do it geometrically as well, but that would be 75 miles per hour times 3 hours, whatever that is. Okay? We can also graph this. So if I draw the graph, and this is my velocity here, and here's my time, and the velocity is going to be 75 miles per hour, and I'm going to go for 3 hours, guess what? It's also equal to what? The area under the curve. This is your time, which is the 3 hours, and then here's your height, which is 75 miles per hour. And if you multiply base times height, you get the total distance traveled. Okay, so that's what we're going to do the second half of this year. It's actually going to go really fast. These are shorter chapters than the first half of the year, which you're going to like. So how are we going to do this? This was easy because that is a rectangle. So we're going to have to what to do if it's not a rectangle. I'm going to squeeze my little pictures in here. So I have a velocity graph. It goes as t squared. T is positive, or 0. And it says, where is the particle at t equals 3? And we're starting at the origin. That does make a difference. So for right now, we're always going to start at the origin. What's going to happen when we don't start at the origin? We'll find that out later. So here is my velocity. Here is my time. And the area under the curve represents the total distance traveled. So how are we going to find out the area under that curve? I can approximate using rectangles. I could approximate using a triangle. Is that an overestimate or an underestimate? Over. Okay, I draw the pictures. They may ask you on the exam, is it over or under? Okay, so there are 3 different kinds of rectangles we can do. We can also do trapezoids. But we're going to do the 3 different ways. Now, in the book, if they just say RAM, that means use any rectangular method you choose. And I'll show you which one I think is I know is the best. But that's up to you. If they tell you to choose a particular method, you'll know. And so they call the one with the rectangles hitting the curve on the left side LRAMs. Let me show you what that means. I'm going to draw the picture. They also don't tell you how many rectangles to draw. So don't make your life miserable. Keep it easy. Keep it nice, easy numbers, as easy as you can. So here's t squared, and there's 3. So what I'm going to do is I'm going to do 3 rectangles. I don't want to do 4. It's too hard, right? How am I going to divide a space of 3 into 4 parts? That's too hard. How about if I do it in 3 parts? So we'll divide this into 3 rectangles. There's 1, and there's 2. And I'm going to find the area of the rectangles. I don't have rectangles yet, but I'm going to get them. Now, my rectangles are going to hit the left side of the curve for the height. I'm not going to do the first one because that one's kind of confusing. But let's start on the right side and go this way. I want the height of my rectangle to be determined by the function on the left side of the rectangle. It's called an LRAM. So when I do this, I'm going to draw my rectangle so it hits here, and that's what I'm going to use for my height. The corner on the hitting the left side of the curve. So then this one's going to be here. And where's this one going to be? It's going to be an area of 0, isn't it? And if you look at this, over or underestimate? Under. Well, on the exam, these are easy numbers, but on the exam, they want to see your plan. They want to see what you multiplied, what you added up. And we don't even care if you add them up. So to find this first one, the length of the base is 1. Remember, it's just based on height. So it's 1 times that height, which is 0, plus, what about this base? Still 1 times this height, which is what? Remember, this was t squared. So it's 1 squared, right? I know it's 1, but is that okay? What's this height? The base is still 1, so I'm going to make my life easy, because otherwise it gets to be too tedious, and they won't be that hard anyway. So it's going to be this function evaluated at t squared, I'm sorry, this x coordinate evaluated at t squared, which is 2 squared. You get your point for everything right there. And if you just come up with the answer and have no work, you won't get any points. I graded this one last year, so I know. So that's 0, and I like to get the right answer. But if I were on the AP exam and that's what I have, I would stop right there because you get full points. But we're going to go ahead and figure it out because I want some numbers here, and that's going to be 4. So using an LRAM, I get an area about 5. She told me it's an underestimate. By drawing the curve, by drawing it. I'll let you, well, I'm going to leave it open for you to decide how you know it's an underestimate. What are the conditions to get an underestimate? Yeah. But I'm going to leave it open for you to discover when you get an underestimate and when you get an overestimate. Using midpoints, I will not know, by the way. Okay, so now we're going to do the same problem, but we're going to use the right side of our rectangle. Oops. Well, that's close enough. And again, I'm going to divide it into 3 of them. So there's 1, 2, and 3. And I want my rectangles, I don't have rectangles yet, I want them to, the height of the rectangle to be determined by the side that hits on the right side of my rectangle. So it's over here. Notice I didn't use this 3 in the previous problem. Because that could be over or under. Over. And then I want this rectangle, but I want the height to be determined by the side on the right side of the rectangle. So I'm going to use the right-hand side. And I am going to get a rectangle here, aren't I? Okay, do you see how I'm drawing the rectangle? This is what I mean by the right side. So if you look at your rectangle, I look at that right-hand corner, and that height's determined by the curve. This one was the left side. Okay, so what's the plan? It's the base times, now what's the height here? This x coordinate, 1 squared plus, then it's going to be 1 times, then what's this height? 2 squared, I want the plan, plus, and then I'm going to do this height, which is what? 3 squared. You'll get credit for saying 1 times 1 plus 1 times 4 plus 1 times 9. But if I don't have to evaluate it, why bother? Because if I do 3 squared and I accidentally say 6, what's going to be wrong with my answer? It's not, yeah, it's not going to work, is it? So why not just show the work and leave it? Time is going to be an issue. But I want to know the number, so I'm going to show you some things with your calculator. That's 1 plus 4 plus 9, which is a grand total of 14. One thing you could do would be to average. Is that okay, Stephen? What else could you do? Could you divide it into more rectangles? You could divide it into lots and lots of rectangles. So many rectangles you can't see them. We'll do that with our calculator. So the more rectangles you do, the better the estimate. But it makes me think that I'd like the number of rectangles to become infinite. Sounds like a limit to me, right? These, by the way, when you find the areas under curves using rectangles, it's called a Riemann sum. Now, that sounds scary. They're going to use this word on the exam, and that's the name of the German mathematician. He got credit for it. Newton probably was the one who did it. Everybody gets credit for things they didn't do. Do not get nervous when you see Riemann. It just means you're going to find the area under the curve. Change it to Golembeski. There you go. Because that's all it is a name. I like these. When you see a circle or a triangle on your exam, the minute you see geometry, you know how to do geometry. You go, oh, I'm just going to find that area using geometry. There's ways to do it with calculus, but you're not going to use the calculus. But we'll talk more about that tomorrow. Let's do the midpoint rule. This is the most accurate, and you can see why when I draw it. So I can draw a straight line. That's better. I know it's not to scale. Bear with me. Now, the only thing that's wrong with this is the numbers get a little trickier. I want, on the midpoint rule, the height of the rectangle to be the height of the graph using the midpoint. So I'm going to find the halfway point here, and I'm going to draw my little rectangle. So there's a little bit above and a little bit below. I don't need as many rectangles. So I'm going to find the midpoint here, which is right there, and I'm going to go up to that, and that's going to be the height of my rectangle. So some will be above, and some will be below the curve. Does that make sense? I'm going to say something. So I find the midpoint here, and I go up, and that's the height of my rectangle. It's the best one of all. Okay, so where are my midpoints? Where is this midpoint? This is t squared. That's 1/2. I know you guys like decimals. I don't like decimals. You'll see why. Now, I don't want to do 1 1/2. I want to write it as improper fraction. 3/2. And then this is going to be 2 1/2 or 5/2. See the patterns? Okay, so here's the plan. The base is 1, and then I have to find my function evaluated at the midpoint. So it's v of 1/2 plus 1 times the velocity at 3/2. That will not get you all your points, by the way. This is just the plan. And 1 times the velocity at 5/2. I have to actually put the numbers in. Then I get all my points. So what is the function I'm going to do? T squared. Do I need parentheses? Yes. Anytime you substitute, you always need parentheses. Sometimes you can get away without them. The problem is you don't always know when that is. Okay, this is 1 times 3/2 squared plus 1 times 5/2 squared. And that's all you need for your full points. But if you just go and give them an answer, even if it's a calculator problem, you will get nothing. You must show the numbers you put into your calculator. But we don't need a calculator, do we? No. What's 1/2 squared? 1/4. Now square this one. This is why you must have the parentheses. It's 9/4 plus 25/4. And since we divided the pie into 4 equal parts, that doesn't change. So we just count how many parts we have. So 1 and 9 is 10, 35/4, which is pretty close to what number? 9. Well, it's closer to 9 than it is to 8. It's a little bit smaller than 9, right? Should we find the exact answer? We're going to need our calculators, and I have some calculators here that you may borrow if you don't have yours. An 83 or 84 will do. So will an 82, but I don't like them. The CAS will do it too. CAS will do everything. You're going to learn one more function on your calculator today. Yes, because I can see it better. Okay, what's my function? It's just t squared, but let's just do x squared. Whoops. X squared. Is that this one? Okay. And then we have to have the window. What would you like the window to be? We want to go from 1 to 3. So how about if we go 1 to 4? Or not 1 to 3. 0 to 4. Let's go 0 to 4. How big is that y value going to get at 4? 16. Well, I want to be able to see this. I don't want it squished. And then we press graph. Is that okay? Do you need a calculator? Okay, we're going to do, there's a couple ways to do it. We're only going to do one way today. Now, I'm going to give you also a program. But, and it's not on mine, and I was going to put it on there. Maybe I'll get it on there by tomorrow. It should always be in radian mode. Yeah, I can look at it. Let me look at it. Let me see, because I know if something's wrong with it really quickly. Yes, you have your plot 1 on. There, now you're going to be much happier. Okay. I love calculating. Are we ready? I don't know why I'm involved. Is this one dead? Okay, ready? Let me see. Oh, I bet you have something down here. Yes. There you go. Okay, so we press second. Calculate. Last thing that we can learn on the calculate menu, and it's this. And that little funny little squiggle thing looks like an S. And in German, the German word for sum is sum, S-U-M-M-E, which means this is the base of my rectangle, it's the change in x, and the height of the y values. So it's adding up all the rectangles. And literally, your calculator does not know calculus, and that's exactly what it's doing. So I press that, and I want to go from 0. I second, calculate, and it was 7. Press enter, and we want to go up to 3. And then we press enter, and it will shade it, and there it is. Yes. Now, because we did, this is a draw function. If you want to see it again, I have to go in here and do clear draw. Second, draw, clear draw. Okay, let's try that again. Are you guys ready? Are you ready? I'm trying to figure out where you start. Well, we only wanted from 0 to 3. I went from 0 to 4. Okay, weird. Okay, ready? Okay, so we ready? Second, and then calculate. You know all these other functions, the value, the 0, min, max, intersect, dy, dx. This is derivative or slope. And so 7 is what I want. And then you have to say, well, where do I want to find the area under the curve between? I want to start at 0, and I want to go to 3. And there it is. And the area is 9, and we were pretty darn close with only 4 rectangles. T-squared grows pretty quickly. If I had 8 rectangles, it would get better. Now, I have a program that will do the number of rectangles, we'll do the LRAM, we'll do the MRAM, we'll do all that for you and show you the rectangles. And you can do 100 or you can do 5, whatever you want, which is really nice. However, it's probably been cleared out of all my calculators. It's certainly not on here. So I've got to get that set up, and hopefully I'll get that done by tomorrow. Okay, I'm going to leave this open. You can figure out overestimate, underestimate. I think it's going to take working on some problems. Well, let's do a homework problem. Let's do number 2. Okay, we'll do 2 homework problems. So you don't have very much to do, really. And yes, I'm going to collect, but at the end of 5-1, I'll collect it. So it won't be due till Monday, even though it should be done. This is homework. Let's see. Okay. Not number 1, it's number 2. B of t, correct me if I'm wrong, is equal to 2t plus 1. We're going to start, they said x, they mean t equals 0. And I forgot, anybody got their book to t equals 2, is it? 3? 4. Because I remember the answer. Now, what does that graph look like? Where does it start? Starts at 1, right? The slope is 2. What is that shape? Do I have to use calculus? No. Anybody recognize what that shape is? We might as well get this in right now. It's a trapezoid. So as long as it's geometry, I may use geometry. So I'm going to. I'm not going to divide it into rectangles. That'd be silly. You could. Now, on the exam last year, it was the trapezoidal rule. So it was using trapezoids. So if I have a trapezoid, let's find the formula for that. Now, I know what you guys probably did when you did trapezoids a long time ago. You probably dropped the altitude, picked up this triangle, moved it over there, and made a rectangle. But there's an easier way. I like easy. Those of you who've gotten to know me should know I like easier. It's much better. This is the height. This is base 1. This is base. What's the area of this triangle? 1/2 base 1 times the height. Right? Remember, area of triangles. You have to know that. Areas of circles. And that's this one. What's the height of this one? That's the same, right? So this is plus 1/2 the height. And what's its base? B2. That's the formula. That's the area of a trapezoid. But could I factor out what? A 1/2 and an h. B1 plus B2. And last year they asked for the trapezoidal rule. My first year teaching this, I didn't get to the trapezoidal rule. But I figured my kids could figure it out. But that was not good. Make sure you get everything. But you know what this is? It's really this. So there's a couple ways to remember it. They will not give you the formula. You have to know it. What's this called? When you add two bases, add two numbers, divide by 2, it's an average. So if you average the bases and multiply by the height, you have the area of the trapezoid. Well, the problem with this trapezoid is it's on its side. So I'm going to turn it this way. And now you'll see it a little bit better. Here's the height. But guess what? That's this length here. Here's one base. That's this length. And here's this other base, which is that length. So it's 1/2. I always do 1/2 the height. This height is this length here, which is this length. How big is the height then? 4. And then it's the sum of the bases. How tall is this? 1. And remember, the formula was 2t plus 1. That was the equation of the line. So how do you find the other height? How do you find this height? It's 2 times 4 plus 1. I'm going to put parentheses to see it's a separate height. By the way, that would give you full credit. But we're going to find it out. Because if we can do this one, this is exact. Let's have the 4. 2. Then this is 1 plus 2 times 4 is plus 1 is. So the answer is I could use geometry, which is nice, but on the next problem, which I think we did was number 10, we can't because it's curved. And you could find the area of your hand. You could trace your hand and you could divide it into little rectangles. You could do that. So everything we're doing, is there any calculus here? It's all geometry. Not yet. And I like this better. Okay, here's my function, and we're going to find the area from x equals 1 to x equals 3. And they don't tell you how many rectangles. They don't tell you which method to use. I like midpoint. It's always the best. It's even better than putting little trapezoids under the curve, which we'll do. Okay, you guys remember what this looks like? The answer should be yes. This is on your sheet. This is a hyperbola. And I want from x equals 1 to x equals 3. Now, I don't want to kill you with doing a whole bunch of rectangles. You could do 100 if you wanted, but that's crazy. What would be a nice number to pick since they don't tell us? 4 would be good. It's still a lot of work. What's even easier? 2. Let's just do 2. Because you know what? If you can do 2, you can do 4, can't you? Yeah. But you could do 4. You'll be shocked. I was shocked at how good just 2 were. Okay, so what are we going to do? We're going to put them left side, right side, or midpoint? Midpoint. I'm still going to have fractions. If you do 4, you're going to have more difficult fractions. That's all. So where is this going to be? Halfway between 1 and 2 is 1 and a half, which is 3 halves. So some is going to be outside, some is going to be inside. How about the next one? Where's this going to be? 5 halves. If you do enough of these, we can do an infinite number and you'll see patterns, but we're not going to do that. Be thankful. We used to do that. Okay, so we're just going to find the area of my 2 rectangles and be on our way. So the area of this rectangle is the base, which is 1, times f of, what value am I going to put in for to find my height? 3 halves. I want to do it this way because it's easier than doing decimals. You will see. And the next base is 1, and this height is f of 5 halves. We're only going to do 2 rectangles. Now, if y equals 1 over x, what really is that? It's a special function. What if I have 1 over 3 halves? What's that equal to? 2/3. What did it do to 3 halves? It's a reciprocal function. That's how I do it. I don't think about the algebra to go from here to here. I just, oh, it's a reciprocal. So it's 1 times 2/3. What's the reciprocal of 5 halves? 2/5. So now I have to add up 2/3 plus 2/5. And yes, this can be a challenge. Common denominator. And it's not that hard. But if you had 4 of them, you'd have to have more common denominators. When in doubt, multiply the 2 denominators together. It always works. It's not always the simplest fraction. If I were to go back and teach middle school math again, well, it's probably elementary, I would just say multiply them together all the time. Forget finding the least common multiple. So what does this have to be multiplied by? 3. And then this is going to be 3. What number is that? 3 over 3 is 1. You don't change the value of that fraction at all. What's this one going to be multiplied by? 5. And so then when we do that, it's not that hard. Yep, you get 16/15 because I get 10/15 here plus 6/15 there. Some of you want to add the denominators, but you can't because that's how big you divided the pie into. That's the size of the slice. So it's 16/15. Well, let's find out how good that was. And we did it last hour, so that's why I know how good it is. So let's graph this. Let's practice this one more time with our calculator. So y equals, I'm going to clear that out. 1 divided by x. And you know what? We can keep the same window, but what's the biggest y value we're going to get? If we start at 1, the biggest y value we're going to get is 1. So why don't we go from 1? Yeah, that doesn't look too bad. And then we're going to go ahead and do second. Are we ready? Calculate. And we want 7, which means add up the areas of all the rectangles, and we're start at what? 1, and go to 3. So 3, yeah. 1.0986. How good is that? That's 16/15. I'm lazy. I'm going to use my calculator because I have it out. 16 divided. This is only 2 rectangles. If you did 10, you're going to be. It's going to be right there. You can do as many rectangles as you want. 1.066 versus 1.098. Not bad. I even think if you did 4 rectangles, you get even better than this. Now, the program I have will do that, and it'll show you the 4 rectangles. And it's just a matter of punching a button. But you have to be able to do this by hand. And what's the minimum you have to show? This. By the way, you can just leave it on the free response. Yeah. But you have to show what you multiplied. And we'll go ahead and do last year's problem. I'll bring it up. I know it's not in our handouts because our handouts from previous years. And that's all there is. That's what the homework looks like. So now the question is, what are your questions on here? By the way, the answer to number 4 is incorrect on the answer sheet. It's -1. I didn't do it. It's -1. So we still have a lot of time for you to ask me questions. Yeah, we have to use calculus. It's an antiderivative. You can't do it yet. We haven't done it yet. We will. So you have to ask me what your questions are on. We had a lot of good questions in the last class. It's online. I will show you where it is. Because I have it up. Okay, so. Yeah, we will. You go into AV materials. I'm showing you where the answer sheet is. Maybe. Sometimes it's difficult when I'm at the smartboard. Okay. You go into the materials, and you might have to go down a little ways. I can put it up at the top if you want, but there it is. Basic skills algebra. It should come up. Which one are you going to ask me to do first? Number what? Number 3. You forgot what normal meant. Yes. There they are. That's a perpendicular. Okay. Okay, I don't know what the function is here, you guys. And I'm going to actually try and draw this better than I did last class. Does everybody get number 3? The normal line. 3 is the thing that Okay, we will. This is the tangent line. Okay, guys? The normal line is the perpendicular. So if the slope of this is negative 3, what is the slope of the perpendicular? 1/3. It's the reciprocal and it's the opposite. So now that you have this and this, you should be able to write the equation of the line. I can stop or I can do more. Okay, so number 4. You asked for 4. The answer is -1. It's always in math. I can't prove it, but it's always 2 changes. What you do to the denominator, you do to the numerator. So when I flip this, I have to have another change. I change the sign. It's just a quick little check. I can't prove it. I've never seen anything in math where I've made one change without having to make at least a second change. When you divide fractions, you multiply by the reciprocal, 2 changes. Okay. Now, when you guys take a line, when you take this line here, this is a picture of all the numbers that make that sentence true. And there's a whole bunch of numbers. You cannot list them all. That's the solution to that equation. So when I'm looking here, I want to find k, and it says that this line goes through -2, 3. It says the equation of the line that passes through this point is right there. Find the k value. Well, if this point is a solution, it lies on the line, I can just substitute it in there. That's all we're going to do. So make sure you put the y's in the right place, because it's easy to put them in the wrong place. And then it's -2 minus 4. So it's 3 minus k equals -2/3. What's -2 minus 4? -6. Now, I don't know. Do you know how to multiply fractions? Multiply the numerators, multiply the denominators. So what's 12/3? What's -2 times -6? 12. 12 divided by 3 is 4. As long as there's no adding there, I'm okay. Now, do I have to solve that, or can I just guess and check? Why don't we just guess and check? 3 take away what will give you 4? K equals -1. We can solve, but there's nothing wrong with guess and check. The problem is we learned how to solve because sometimes we couldn't guess and check. Now, in my algebra class, they still have a tough time with that negative. They throw it away. Or even if they get to this point, they still don't know what to do with it. It says the opposite of some number is +1. Opposite of what is +1? Opposite of -1 is +1. More questions? Somebody said something about 10. You want to look at 10? 10 is hard algebraically. We can do both. I think we have time to do both. Write this as a single log. First, let's review properties of logs. Honestly, there's 3 things you need to know, because you don't have to evaluate. You can leave it the natural log of e squared or whatever it is. And the log of x to the r can be rewritten as r times the log of x. Remember that one? By the way, you go forward and backwards. What about the log of a times b? And on the exam, it's going to be a natural log. You hope it's not another log, because those are harder. Now, remember, logs are exponents. If you have the same base, what do you do with the exponents? You add them. So if you have the same base and you're dividing, what do you do with the exponents? You subtract them. And that's it. That's all you have to know. That's everything there is to know about logs. Okay, so now we'll do the problem. And it's not that bad. Now, to combine to make a single log, you can't have that 3 out in front. I'm going to put a parenthesis there just to make sure that we're clear. Yep, it all has to be just plain log. So it's log of x cubed. And you know you are going to see logs on the exam. 2 out of the last 3 years, they've had log equations to solve. Let's go left to right because that's what order of operations says we do. So let's do this. Well, that's the log of x cubed divided by 3x. Now, the ln doesn't go away. It's the log of that. You can't separate those things. You can't just get ln. It's ln of x. Now, that's the adding one. Remember? It's this one right here. So you just multiply them. I'm just going backwards, that's all. Usually I start with something complicated that I'm going to come up with and change it to what I started with. No. There. And can you simplify that? Give me kind of. Doesn't 3 go into 12? Can't you reduce that fraction? I'm not going to put equals because it's not an equation. So this gives you x squared. How many times does 3 go into 12? 4. So it's the log of 4x to the 4th. And yes, you could go and expand that out again if you want, but didn't ask us to do that. No, I divided. 3 goes into 3 once, goes into 12 4 times. No, because it's not an equation. You're simplifying. When you make it equals, now you're saying it's an equation. It won't mark off unless you make things that are unequal, equal. Then they'll mark off. Okay, do you guys need to see number 10? You got number 10? No, it is not a limit. It's an average rate of change. Guys, it's not time to go. It's not Tender Tuesday. Then I have my laugh forever.